Find the equation of the graph, they ask. So we've done practice before where we're given an equation and then we have to produce a graph from it. Now we're working backwards. Given the graph, figure out what equation did this come from. Now, we're accustomed to giving our line equations in what we call slope-intercept form, where the y and the x are just there, and the information is that this number in front of the x is our slope, and this number on the end is our y-intercept. And for a nice line where the y-intercept is a clean point, unlike this looks like it might be minus 0.5, 0.4, something like that, and where the slope is easy to count, you can just read those numbers off the line and plug them in. And I think through our examples later we will get a chance to see that. But let's assume that we need some really exact values for these, for m and b, and that we aren't confident picking them off the drawing like this. There must be another way, a more accurate way. And there is. It still involves reading points off the graph, but let's see if we can find some well-defined points on this graph to read. This point looks like it goes pretty much right through an intersection. I would call that 1, 0. With fair confidence, I'm going to say those coordinates are 1 and 0. Are there other points like that that are easy to read? Definitely not that. That's not so good. That's not real good either. No, not really. This is okay. What are the coordinates there? 1, 2, 3, 4, 5, 6, 6, 2? If you looked off to the left, you might have noticed this point also, minus 4, minus 2, and that's not so bad either. I'm going to work with these two, and let's see what they can tell us about this graph. Well, first of all, if you have 2 points, you can calculate a slope. We have a slope formula that says slope is rise over run, meaning it's y2 minus y1 over x2 minus x1. This is the difference in the y-coordinates. That's what we call rise. This is the difference in the x-coordinates, which we call run. So if we do that with these 2 points, for the y's we get 2 minus 0 over, and for the run, 6 minus 1 equals 2/5 or 0.4. I'll go with the 2/5 for this, but if you want to work with the decimal, that's fine. So that tells us our slope. That means our line, y equals mx plus b, is actually y equals, we know the slope now. Okay, so suddenly we're half done. We've got the slope. All we need now to finish this thing is a b value. Well, these points can help us again. These are an x-coordinate and a y-coordinate. We can plug those into our equation, and when we do, we'll know y, we'll know x. The only variable left in this thing will be b, and we can solve for it. So let's see how that goes for us. If x is 1 and y is 0, we get 0 equals 2/5 x plus b. 0 equals 2/5 plus b. That gives us b equals minus 2/5. Okay, so our finished line with all the information in it is y equals 2/5 x, we knew that already, plus, and our b value is negative 2/5. And there we are. So if you're lucky, you can read these values off the graph, but you can always do this where you find 2 points, use them to calculate the slope, and then feed one of those points into the resulting equation, and you can use it to solve for b. That will work every time as long as you can read a couple good coordinates off of your graph.